Hello, students. This is a really short video on how to use GDS 1.03. This software program done by Dave Rowe is very powerful, and it marries up the Washington Double Star catalog with a survey he did of all the Gaia DR2 data, where he found 6.8 million potential doubles. So it's a particularly good tool for doing speckle for the close binaries, which are hard to identify, and also it brings the data together so that you can use it for your resume. It's called GDS 1.03. There'll be a shortcut on your desktop. That'll be an icon that, at any rate, when you open it, you hit run. And the first thing you have to note is you have to down here reading GDS catalog. Before you start anything, it needs to load all the data. And it's a lot of data. So you see it going through here and it loads the Gaia data, then it loads WDS. Okay. You see up here it has 6.8 million Gaia doubles. These are theoretical doubles, unproven. And then there's 139, there's really 150,000 in the WDS roughly right now, but this is close enough for right now for our work. As you see up here, you don't need to have this, get rid of these. And that's for doing a target list, which we're not going to be doing right now. As you see, you need a target list. But here you can pick minimum, maximum for all these categories. So this gets you to sort through all that data down to something manageable. And once you've got that, you can come down here and you can write a file that you can save to your computer that you can do further work with in Excel. So having that ability to do that within Excel really adds to the flexibility. And most of the data that you need for your resume will be here. And for the preliminary work where you need to have parallax and so forth, it's here in most cases. Well, I'll take it back. It may not be here, but it's in many cases it will be. So in here, we've got an example. You can put in, let's put in let's put in something like 20. Notice I put spaces in there, and we'll go up to, let's say, 22. Oh, okay. 20 to 22 RA. I'm going to look at it in Northern Hemisphere because I'm thinking about doing a speckle, let's say. So I want it to minimum, I want to say is -10. Okay. And the maximum, let's make that 40. Actually, let's make it 50. That's not a bad range for observing from Barrow. Magnitude, no, I want to do it from like magnitude 7. This is magnitude 0 is the A star, the primary. And for the B, I'll leave it the same because I'm going to say maximum delta magnitude. Difference in magnitude is 2. So maybe there'll be a 7 and a 7. That's okay. But there won't be, you won't get back a 7 and a 10 because that'd be more than 2 difference in magnitude. I want to do separations. I think I'll do 1 to 3 arc seconds and ignore the GB index. That's not important. Here is, if you notice how your values in red are estimated. Yeah, they're really crude estimates based on the information he has from Gaia. What the separation would be in AU. This is pretty close, 10,000. That's that's close enough to be binary. Certainly. And the period under 50,000 years. Okay. And down here, I can select the sort order I wanted in. He's got a set here as period. Maybe that's good. I'm going to do it by RA because I'm thinking about timing of when it's going to be overhead. And you can say You can tell it right here to write to CSV. I'm not going to do that to start with. I'll do it down here. Hit apply. Oh, in your application. If you click continue, the application will ignore this error. Okay, I'm going to hit continue. And let's see what happens. Oh, I see what happened. Very important. Let's see if we can stop this. You notice over here, it's degrees or hours, minutes, seconds. I defined everything in hours, minutes, seconds. And so it doesn't know how to deal with that. So I'm going to start over. I will close this. It's not going to, Windows is not going to find a solution for it. Close the program. Okay, let's try that again. Run. I got to let things load. I'm going to come over here. So I don't forget, I'm going to go ahead and be sure I click that hours, minutes, seconds. And I'll go back here. Remember I said 20. And this is going to be 22. And this is going to be minus 10. This is going to be up to 50. And I said 7. 7. 12 might be a little bit faint for us. Let's take this down to 11 and 11. And that automatic is on. I'm going to make this 3 arcs and 1 to 3 arcs. Ooh. And I ignore that. Distance in parsecs, 200 is reasonable. It's reasonably close, which will make it more interesting. I will leave these parameters there. Notice these. I don't worry about 3-band photometry, but do WDS and period must be computed. Period must be computed. Well, I'll get rid of that. That's a little bit much, but it will only return things that have a WDS number. Now, if I were looking for things that are not in WDS, then I'd uncheck that. Okay, so as I said before, I think I'll do it in RA order. We got this set right. Now, cross our fingers, we'll do apply. There it is. Okay, you see right away, it's a pretty big file. Now, you could narrow these down, or you can just write the CSV file and then work it in Excel or Sheets yourself. So write the CSV file. It's going to be right there. Give it a name and save it. Okay. So there's how you do it, and even with a bug in it. So keep in mind, I tend to work in hours, minutes, seconds, and most of the records in the catalogs are expressed that way as well. Okay, hope this works. I hope this works for you. Take care. Bye.